Hello everyone, I'm Cassie Savakinas from First Robotics Competition Team 4575 The Tin Mints, and I'm here to tell you a little bit about how you will start programming your first LEGO League robot, specifically how you can turn and go forward. The basics. This is the first block you will use when programming your robot. This block will tell your robot to go forwards or go backwards. Because this is in the movement section, because it is pink, it will control two motors, and this is automatically set to the motor plugged into port B and the motor plugged into port C. For the purposes of this video, and what I recommend you all do as well, the B motor will be the motor on the left, and the C motor will be the motor on the right. Within this forwards block, you can change whether you drive forwards or backwards. You can also change this number, which you can set to be the number of rotations, seconds, or degrees that your robot will move. I recommend that you always use rotations, because that is what I'll be using in this video, and it's the easiest to understand. Something very important with degrees is this is the number of degrees that the motor will turn. So if the motor turns one rotation, it is also turning 360 degrees. So how do you make your robot go forward for a set distance? As I just said, 360 degrees is equal to one full rotation, as you can see here. And the way you will figure out how far you want to go is you will need to make a program to have your robot go forward one rotation. And you will want to measure the distance between the axles of your wheels when you start the program and the axles of your wheels when you end the program. As long as you do not change your wheels, that number will be the same throughout for the entire program, for everything that you would want to program. If you change the size of your wheels, you'll have to come up with that number again. So the distance that you want to go divided by the number of inches in one rotation will give you how many rotations you will need to go. And that is the number that you will put into your programming. Now, degrees are something very important, especially when turning. There are lots of different angles or set numbers of degrees. It could be 0 or 23 or 92. But the most common that you will use are 0, 45, 90, and 180. And we're going to use our little whale friend here to understand degrees. So right now, our whale has turned 0 degrees. That's because it hasn't moved. When the whale turns 90 degrees, it will be facing directly to one side of its body. Currently, it has turned 90 degrees to the right. When the whale turns 180 degrees, it will be facing the opposite direction that it did before. When the whale turns 270 degrees, it is now facing the left. You may notice that this is also turning 90 degrees to the left, and they will end in the same spot. And if the whale turns a full 360 degrees, it is back where it started. However, if you want to turn a certain amount that is not one of these angles, you can do that. For example, our whale has turned 45 degrees from where it started, which is exactly between 0 and 90 degrees. So programming turning. What we will learn about is called a pivot turn, and this is the most basic type of turning and what I recommend you start off with. To turn to the left using a pivot turn, the B motor, or the motor on the left, will not move. However, the C motor, or the motor on the right, will move. This means that your robot will turn to the left, and you can see that that C motor would follow the path of that blue arrow until the front of the robot is facing the left. I understand this doesn't exactly look like a robot, but my artistic skills are not the greatest, so you'll have to use your imagination to hang in with me on this. Now, if we want to turn to the right, the B motor will turn on, and the C motor will not. This will cause the robot to turn to the right, and the B motor will follow that maroon line over to where it says right. Now, how many rotations are in a 90-degree turn? And this is referring to a robot turning 90 degrees, not a motor turning 90 degrees. And the answer is it depends on the distance between your wheels. As you can see here, we have another robot that also looks like 3 rectangles, but it's okay. And that orange line is the distance between the center of one wheel to the center of another. And both of the orange lines are exactly the same length. If you see that maroon arc, that is the path that the B motor, or the motor on the left, will follow. How I recommend you see how many rotations you will need to make a 90-degree turn is to just try doing it. Try 1 rotation, try 2 rotations. But the best way to do it is try making a 360-degree turn with your robot. If you remember from earlier, that means the robot will end in the exact same spot that it started, and then just divide that number by 4. However, you can also use this fun formula involving the distance between your wheels and the circumference, which is the total perimeter of your wheel, to figure out how many rotations will be a 360-degree turn. To program a pivot turn, there are 4 different things that you can change. In this instance, we will be turning on the B motor. So that means, if you remember from earlier, we will be turning to the right because the left motor is turned on and the right motor will not move. It will run clockwise. For most robots, that means that it will go forwards. However, if your motors are upside down, that means it will go backwards. And that's just something that you can change really quickly. And it will go for 1 rotation. This may make your robot turn 90 degrees, or 63, or 130. I don't know. It depends on the distance between your wheels. And then you can change if that number is for rotations, degrees, or seconds. Again, I highly recommend that you use rotations for that. So now take a second and go look into the EV3 Classroom programming. Try and understand how this programming works on your robot. Try and figure out what a 90-degree turn is, how many inches are in 1 rotation, and those really important pieces of information. And make sure that you write them down somewhere that you will be able to find every meeting. Make sure that you have it at your meeting location, and it's not just one person that has that information. Good luck, teams! And if you have any questions, feel free to ask your mentors.